Do you guys like VPython? This is not VPython. This is a globe. Maybe you've seen one before. I want to do, so I'm making a picture. And sometimes the best way to make a picture is to just program it in VPython. And so that's what I'm going to do. I want to make a globe with the lines of longitude and latitude on it. And even the poles, maybe. And then I want to make a celestial sphere. I have a celestial sphere, a real celestial sphere, but I didn't want to go down the hall and get it. But if you don't know what a celestial sphere is, it's basically a longitude and latitude system in the sky. And it's not going to be perfect, but it's going to be my model that I can then use in my classes. So let's go ahead and jump into VPython, and let's just start coding. Right? We're going to start coding stuff up. We're going to make this happen. So switching over here to VPython. If you haven't used VPython at all, welcome to VPython. So I will give you the code after. I will give you the code below. Okay. But you guys I think you guys like it when you know, Python stuff. Let's just get started. So I already have in here a program I printed R just because I like to print it once before I save it, because sometimes it does weird things when you save it. And R is just the radius of my Earth. I don't have to use real units. I want to make a picture of it, right? So let's just start off with a simple thing. We can make the Earth. Earth equals a sphere. So in VPython, if you haven't been familiar with VPython, we have these 3D objects. One of them is a sphere. And so I'm going to put this at the location of the center of my coordinate system, 0, 0, 0, and then I'm going to give it a radius r. And then I'm going to run it. And it's not the globe, right? I'm building up. I'm assuming you haven't seen stuff like this before. So there's my sphere. If you right click, you can drag it around. There is a light source. You can zoom in and out, but I want to make that look like the Earth. This one's really easy to do. So to make it look like the Earth, there's a built-in texture that you can use. I can say there's a property called texture equals textures dot earth. So that will give it an Earth-like texture. And if I run that, bam, look at that. There's my globe. But it doesn't have the lines longitude and latitude on it. And the other thing I like to do, I like to turn, there's a couple things that make the lighting a little bit better. So I'm going to turn this on. Let me put a comma right there and wrap this around. I'm going to say shininess equals 0. So now it's not a shiny Earth, it's just a flat Earth. See how that looks a little bit different? Now, there's another problem in that the default light sources, there's lights here, and I don't remember where they are, but I want to change this, and this is something that I forget, so I'm writing this down. So the first thing I'm going to do is to get rid of the lights, okay? So I'm going to get rid of the lights up here with what's called, I just do scene.lights equals an empty list. So there's a list of lights, and if I set it equal to the empty list, then there's no lights. Now you can still see stuff, and I don't really remember why. I think it's because it's maybe partly emissive. I'm not really sure. But there's my Earth. You can see there it's very dark. Let's just try. I'd like it to be completely dark, but let's not do that yet. Let's add a light. So let's put a light in the negative x direction. So I'm going to say it's a type of light called a distant light. And I need to give it a direction. It's going to be equal to vector. I can't remember the direction of the light or the direction it shines. Let's just say -1, 0, 0. Let's see, is that all I need? Yeah. Let's just see what happens there. Yeah, that's it. So as I rotate around, so it's in the negative x direction. So that's pretty good. And you can see the shadow right there. Now let's just try one real quick thing, and I don't know about this. I'd like to make it perfect, but shininess, and let's say emissive equals 0. Is that something? I don't know if that changed. Okay, I'm going to leave it like that. We can play. I'm not really worried about the phases of the Earth. I'm really worried about the lines of longitude and latitude. So that's that. Okay. So let's start adding in our lines. Let's start with our latitude. Okay. So to do that, I need to first say, well, how many degrees am I going to make it? I'm going to make it every 10 degrees. So let's call this, I'm going to start with the angle. I'm going to call it alpha as 0. And then d alpha is, oops, got to spell it right. D out, you don't have to spell it right. It's going to be 10 degrees, so 10 times pi divided by 180. I'm going to put it into radians. Okay, so then what I'm going to do is draw a ring around the equator. Let's just start with that just to see if it works. And then we're going to move that ring up. Now, as we move the ring up, I'll switch to the board and I'll show you what we're going to do. Let's just make a ring. A ring is an object that has a position, and this equator one's going to be at the origin. This is going to be vector 0, 0, 0. That's the center. The axis is going to be the vector direction of a pole going through the middle of the ring. You don't need any magnitude on there, but I just need a direction. So I want the axis in the y direction. So axis is going to be vector 0, 1, 0. You can rotate and stuff like that. Now the other thing I need is the radius. I want the radius of the Earth. So radius equals r. Okay, this is going to be wrong, but let's run it anyway. So there's my equator. Not what I wanted because it's too thick, right? So let's change the thickness of my equator with the command thickness. Thickness equals, and I can't remember how they define this. Let's just try r over 100. I don't remember what the rules for. That looks pretty good. Good guess. There's my equator. See? Oh, and you can see right here a couple of important things that are fun to look at. What percent of Africa is in the southern hemisphere? It's like 30%. Most of it's in the northern hemisphere. That's fun. That's one of those fun map questions for you. Okay, now let's just make a whole bunch of these. So I'm going to actually put these in a list, even though you don't you don't have to. I don't need that first one. So let's make a list of lines called lats. It's an empty list. And then what I want to do is to increase my value of alpha until I get to pi over 2. So while alpha is less than pi over 2, then that'll go up to 90 degrees, right? 90 degrees is where the North Pole is. Okay, so the first thing I'm going to do is to just I need to switch. What am I going to do for that first one at 10 degrees? How am I going to make that ring? Let's switch over to the board so we can draw it out, right? It's going to be helpful to draw it out. Okay, so here we are on the board. So here's my Earth. Here's the equator. That one's really easy, right? But now the next line of longitude is going to be up here. It's a little bit smaller. Let me even make that even higher up just so we can emphasize where that is. So it's up here. There's my axis. There's my origin. So the location of this, I need to find the location of that for the center, and I need to find the radius. So let's just say this is my radius of the whole thing, r, and this is the angle alpha. If that's the case, then my height is going to be this. Y is going to be r sine alpha. So the origin of that's going to be 0 r sine alpha, r is 1, sine alpha 0. The radius of this is this side right here, so I'll call that lowercase r. That's going to be r cosine alpha. So I can find the location of my ring, I can find the radius of my ring right there, and then I can draw it. And then I'll make the next ring. So let's do that. I'm going to make a temporary radius. I'm going to call this is called r. I called it r before. So r is going to be the radius of the ring. It's going to be r times, what did I just say? Cosine. Yeah, cosine alpha. Now I'm starting off with alpha is at 0. So this is going to be, I'm going to make the equator. And then y is going to be r times sine of alpha. And I left it in there as r, even though r is 1, just in case we want to change that later. So now that I have r and y, I can make my ring and add it to my latitude list. So lats equals lats plus a ring. A ring, I don't have it doesn't have a name, but the position is going to be equal to vector 0, y, 0. The radius is going to be r, and then I need the thickness. Thickness equals, what did I say, r over 100. Now, did I delete that thing? Okay, there we go. So let's just, oh, and there it is. Okay, so let's just copy that line, because I want to go up and down at the same time. So I'm actually going to make 2 lats. I'm going to repeat that same line right there, and the only thing different is I'm going to use minus y. Now down here, I'm going to increase my value of alpha. Alpha equals alpha plus d alpha. And let's see if that does indeed work. No, it doesn't. Because too many right parentheses, it happens. Okay, lats, ring, radius. Why do I have too many right parentheses? Ring, there's one parenthesis. Those are together. Too many right parentheses. Ring, position equals vector. Radius equals r. I don't think I have too many right parentheses. Let's just get rid of this. Let's just rewrite it. Is it too many? Oh, up here. I see where I did it. Okay, right here. That one didn't get paired. I've wrapped it. That's my fault. That did not work. But it looks cool. Okay, what did I do wrong? R equals R times cosine alpha y. So here I have position is going to be in the y direction. Oh, I didn't give it an axis, that's why. I have to give it an axis. Axis equals vector 0, 1, 0, and then comma. And then down here I need that too. Axis equals vector 0, 1, 0, comma. See, you can tell I'm doing this live because I'm making silly mistakes. Boom. Check it. Maybe they're too thick. You could change the thickness of the rings if you want to make them a little lighter. I'm going to leave it. I'm going to make it a little bit smaller. I just lied. So this is R divided by 100. Let's do 200. See what that looks like. I actually have two. I have two lines for the equator. I guess that's okay. Now we're going to do lines of longitude. Now, lines of longitude all have a radius equal to the radius of the Earth. However, the axis is going to change, right? So I'm going to rotate around and just make rings of the same size that all go through the North and South Pole. That's how the globe works, right? So let's make another angle. We'll call it theta. Theta equals 0. D theta, again, we'll do it in increments of 10. So 10 times pi divided by 180. And then I'm going to call these longs for lines of longitude. It's going to be in an empty list. And again, I'm going to go all the way around the thing. See, the other one I started at the equator and went up. But here I'm going to go all the way around. Although, I don't need to. Because it goes all the way around. I only need to go halfway. Okay, I think I only need to go halfway. So while theta is less than pi over 2, do the following. So now I need to kind of like calculate my new axis. Let's just go ahead and call this R axis for the temporary axis. And it's going to be equal to, I'm going to rotate in the XZ plane. They're all going to have a 0 Z Y axis. So this is going to be equal to the vector, and I don't know if I get this right or not, but let's just guess. Cosine theta 0 sine theta. And now I can make my line longs equals longs plus ring position equals vector 0, 0, 0. They're centered on the origin. Axis equals R axis. Radius equals R. Thickness equals R over 200. And then I need to increase my value of theta. Theta equals theta plus d theta. Let's see if this works. The most important thing you need in that is theta plus d theta. Oh my gosh, it worked. There you go. Oh, it didn't go all the way around. Okay, so I do need to go all the way around. But that's weird. Oh, it did. Okay, so I do need to go all the way around. Okay, let's do that. That's easy to fix. So, well, it's less than pi. Yeah, pi. not pi over 2, pi. I don't have to go all the way around. I have to go halfway around, which is pi, not a fourth of the way around. And now we can do our second map question, right? Which is, what percent of South America is east of the United States? And so right here, there's Florida, right? And you see that there's Maine up there, I guess. But, you know, maybe somewhere around here, but most of South America is east of the United States. It's just one of those things you don't think about. You think it's like right below it. It's not right below it. Okay, those are the two fun globe questions. Let's go ahead and put the poles there. So it's really just one pole. So a pole, I'm going to make a cylinder, and that cylinder is going to go from down here through there up to the top. So it's going to be in the middle of it. I'm just going to call it a pole. Pole is equal to a cylinder. Now, its position, I'm going to start from the origin. I need to go down. If I go down r, it would be at the pole, and I wouldn't stick out. So let's go down. Position equals vector 0, negative 1.1 times r, 0. And now for the axis, it's going to be equal to vector, spell it right. Can you even see that? No, you can't. Vector 2.2, no, 0. 2.2 times r, 0. So I need to go up 2 radiuses and a little bit more to get there. Now I need the thickness, which is just the radius. The radius, let's put that at r over 20, and let's make it yellow. Color equals color dot yellow. And let's see what that looks like. Okay. Yeah, not bad. Right there's my pole. A little thick and not tall enough, so let's just fix that. Make it thinner. Let's make this r over 100. And then let's make this 2.4, 1.2. It's art. You can make it however you like. Okay, but you see here that this could be super useful. If I'm drawing something, I can take a screen capture of this or even make an animation of it if I wanted to. And you could play with the lightings, right? And you could make the lighting really cool too. I didn't do that. I'm really just focusing on that. Now I want to make the celestial sphere. The celestial sphere is the same thing, right? It's the same lines of longitude and latitude, except we call them right ascension and declination. And so I need to make them bigger than this, and I'm going to put them out. So let's put them at twice the radius of the Earth. You can make it as large as you want. And this is actually not too hard because I've already done all the hard work, right? So right here, let's do the lats. I'm going to copy all of this right there. I'm going to call it the lats is the right ascension. The right ascension, declination. No, it's declination. I get those backwards all the time. I can't remember which one. So it's called dec equals blank. And let's say r equals 2 times r. So I don't even have to change that. And then I'm going to paste the rest of that stuff. And I'm going to call, I don't need that anymore. I need alpha. Alpha, that's fine. R's change. And this is going to be dec. 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 And now let's just run that. And there you go. That actually looks pretty cool, don't you think? Now let's add in the right ascension. So to do that, I'm going to copy the longs. I had to reset theta is equal to 0, right? So theta is equal to 0, and I'm not going to call it longs, even though I could. I don't need to change the value of r. I've already done that. Let's just call this RA, and then down here, I just need changes to RA and RA, and I think it should work. There you go. So now I have my Earth, I have my celestial sphere. If you want to zoom in and stuff, you can change things around. But you can see how useful this would be. Now you could even make this so that the Earth rotates. Not an easy thing to do because Actually, I know how to do it now. I was thinking you can't, there's a thing called a compound where you group a bunch of objects together, but you can't group objects together if one of them has a texture. So you can't because the Earth has a texture. But you could treat the two separately, and I want to do that now, but I'll do that in a later thing. So this is good enough. You could also like put some stars on the outside of that thing. That'd be pretty cool. Might want to do that. But if you really need to see that, let me know. I will show you how to rotate the Earth and to put stars on there. Maybe put the ecliptic on there. That's another thing that you often see. But that's that. Hope you enjoyed. I'll put the link to that code down below. And I am out of here. Talk to you later.